I welcome you all the video lecture series of design analysis of algorithms. Already we have seen in the last video what is the Prim's algorithm using the greedy technique method to find the minimum spanning tree. So in this video we will know about what is the how to find the minimum spanning tree using the Kruskal's algorithm in the greedy technique. So already we know that what is the minimum spanning tree. It is a subset of graph. Spanning tree is a subset of graph which has covered all the vertices with the minimum possible number of edges. So the spanning tree, what is the constraints of forming the spanning tree means it should not form any cycle, and it visit all the vertices, and all vertices should be connected. So to find the minimum spanning tree, we have two types of algorithms, Prim's and Kruskal's. The Prim's algorithms start with a vertex. From that vertex, we find the adjacent vertices. From that adjacent, which one is the minimum distance so to go to that vertex from the source to that vertex. This is the process of constructing the minimum spanning tree using the Prim's algorithms. In today's lecture, we will know about what is the Kruskal's algorithm and how to find the minimum spanning tree using the Kruskal's algorithms. In the Kruskal's algorithms means it is a three-step process. First, sort all the edges from low weight to height. So from the given graph, first sort all the edges from low to high. And next, now take the edge with the lowest weight and add to the spanning tree. If the edge is added, if the edge is to be added, that forms a cycles means we have to reject the edge. So continue to add the edges until we reach all vertices and the minimum spanning tree is created. This is the procedure for the Kruskal's algorithms. So what is the first step? We should sort all the edges based upon the weight from low to high. For example, consider this is the graph. So in that graph, first step, we have to sort all the edges from the low to the high based on the vertex. So for that, first minimum is a D2E with the distance 1. Next minimum is that we have two minimums. One is an A to B, other is a B and D. Then other minimum distance is a two vertices with the distance 3. So write it down, A to C with the distance 3 and C to E with the distance 3. And also we have a D to F also with the distance 3. So the next another distance vertex is the 4. So with distance 4, so for C to D, write it down the distance 4. Next one is that E to F with the distance F, and C to B with the distance 6. So form the table with all with that should contain all the edges with weight from low to high. So from that we form the vertexes. Start with the minimum vertex, that is D to E. So form the and connect first step, we mark all the vertices, that is A, B, C, D, E and F. Then step 2, from A, which one is the minimum edge? D to E. So form the D to E edge from for the vertices D and E, and second minimum is A to B. So form the edges A to B, and another minimum is B to D, and form the edges B to D, and another edges is A to C. So another edges is A to C, but then connect that A to C, and before connecting we have to check that connected edge form any cycles. If it is form the cycles means we should disconnected that edge. So the another edges is a C to E, but we connect C to E, it form the cycles. So we are disconnected that edges. Then the another is D to F. So form the edge with the distance D to F. Another one is C comma D. It should when you connect C comma D, it forms another cycles. So reject that edge. Then another next distance is E to F with the distance F. So we check whether we can connect E to F. So the we form E to F, again it form the cycles. And also next check the only one edge is remaining B to C, that is with edge with the distance 6, and when you connect B to C, again it forms the cycle, so reject that edge. So now we check all the edges are connected and all the edges are all the vertices are visited, but this cycle is not form cycles. This graph should not form any cycles. So finally this is the minimum spanning tree for the given tree. So the final step, we have to find the weight from the given minimum spanning tree. So the weight will be the that is 2 plus 2 plus 3 plus 3 plus 1, that is equal to 11. So 11 is the weight for the given graph, that is a minimum spanning tree with weight 11 using the Kruskal's algorithm. I hope you understand this concept. Thank you.